Hello, dear students. So we'll be discussing the integer type questions from the JEE paper that you wrote on complex numbers and relations functions very recently. So let's get started. Most of the integer type questions are actually easy, but I see that students many a times are fearful to answer. Many of them lack confidence. We'll see how most of these are very easy. Let's look at the 81st question. Imaginary part of z is given as 10. And they're also saying 2z minus n by 2z plus n is 2y minus 1. So the moment, first let's assume z as x plus iota y. But y is already given as 10. So it is x plus 10i. That is what is z. Now when you substitute that here, we'll get 2 into x plus 10i minus n divided by 2 into x plus 10i plus n is equal to 2i minus 1. So now when you simplify, grouping all the real terms, numeratorly you'll get 2x minus n and then 20i, and denominatorly 2x plus n and plus 20n. So now I would suggest you can cross multiply here. When you cross multiply, you will get 2x minus n plus 20i is equal to 2i minus 1 into 2x plus 20i. So now imaginary terms should be equal to 20. What are the imaginary terms? Imaginary terms is this and this, right? So I'll get 2 into 2x plus n. So, or we can simplify this. So real terms will be real number into real number. So real terms will be minus of 2x plus n, and then I into I square, that is minus 1. So when you multiply first and last term, you'll get real term. So you'll get minus 40. So this is the real term. And what is the imaginary term? Imaginary term is iota into 2 is multiplied with 2x plus 1. So 2x plus n. So it will become 4x plus 2n. That's what it becomes. And then minus 1 is multiplied with 20i. So we'll get minus 20. So now just compare real terms on LHS with real terms on RHS and imaginary terms on LHS with imaginary terms on RHS. So imaginary term is 20 on LHS. 20 should be equal to 4x plus 2n minus 20. We'll get 4x plus 2n is 40. This is your equation 1. Or you can further divide by 2. 20 agutte. So 2x plus n will get us 20. 2x plus n we get us 20. Now compare the real terms. 2x minus n is equal to minus of 2x plus n minus 40. But 2x plus n, I already know is 20. Then ಇಲ್ಲಿ substitute ಮಾಡಿದ್ರೆ I'll get 2x minus n is minus 60. So now they're asking n value. So two equations ಇದೆ. Add up both. Subtract both. When you subtract, you will end up getting 2n is equal to 80 or n is 40. It's a simple question, but as I said, students must develop confidence that this is doable. Please note down. Then let's move to the next question. So the next question, z minus alpha by z plus alpha is purely imaginary. So again, you can start with assuming z as x plus iota y, and they have given mod z is 2. The root of x square plus y square is 2, or x square plus y square is equal to 4. Keep this condition in mind. And now they are saying x plus iota y minus alpha by x plus iota y plus alpha. This is purely imaginary anta ಹೇಳ್ತಾರೆ. If it's purely imaginary, real term should be 0. Let us rationalize and see what we get as the real terms. And I multiply by conjugate. And I multiply here also the conjugate. So now this is like real terms. Numeratorly real terms I should equate to 0. Which are the real terms? First term and the last term. So nange x square x minus alpha into x plus alpha sigute. So that is x square minus alpha square. Matte iy into minus iy. That will give you plus y square. Why plus y square? Because iota square is minus 1. So minus of minus will give you. So this is the real terms, numerator. These three terms together is real term. And that real term, we should equate it to what? 0. We should equate it to 0. So, but x square plus alpha, y square, they have given as 4. So instead of x square plus y square, substitute 4. So 4 minus alpha square is 0. So alpha is plus or minus 2. So I'll end up here because they're asking a value of alpha, and in numerical type, we don't have an option to put a negative number generally. So we write the answer as 2. Okay. So please note this down. Then we'll move to the next question. Again, first two questions, what was our starting point? Just replace z with x plus iota y, and that itself will take you to the answer. 83rd question needs a slightly different approach. We have solved a similar question in your CET module. Whenever they say z2 by z1 is purely imaginary, we can write z2 by z1 is simply iota times y. So now in this question, what I am going to do is I'm going to divide by z2. Sorry, divide by z1. So I'm going to divide by z1 numerator also. And I'm going to do the same thing in the denominator too. Now z1 will get cancelled here. And wherever I see z2 by z1, I should substitute iota times y. So aga nange 2 plus 3 iota y by 2 minus 3 iota y anta sigante. Now modulus of numerator is root of 4 plus 9y square. Modulus of denominator is also 4 plus 9y square. So therefore, when you divide the two complex numbers, their moduluses get divided. So answer will be 1. Again, very easy question. So the answer is 1. Note down. Let's move to the next question. So 84th is also a question in your CET module. The number of complex numbers such that mod z minus is equal to mod z plus 1 is equal to mod z minus I. What is the meaning of this question? I have discussed in the class that z minus z1. What does this mean? Z is some random point. Z1 is a fixed point. Z minus Z1 andre the line joining these two points. The line joining these two points is Z minus Z. Mod anta tagondre, it means length of this line. It is length of this line. So now when I say mod of Z minus 1, it means distance between Z. Z is nothing but x comma y. And 1. 1 is nothing but, how do I write 1 in the complex plane? 1 is 1 plus 0 I cap. So what is mod z minus 1? It is distance between x comma y and 1 comma 0. Similarly, mod z plus 1. I can always write mod z plus 1 as mod of z minus of minus. So andre, this will be distance between x comma y and minus 1 comma 0. And what is mod of z minus iota? This is distance between x comma y and iota. How to write iota? Iota is nothing but 0 plus 1 9. So in terms of coordinates, it is 0 comma 1. So now they are telling distance from x comma y to 1 comma 0, minus 1 comma 0 and 0 comma 1. All the three distances are equivalent. So where do you think distance will be equal? If you look at, this is 1 comma 0. This is minus 1 comma 0. And this is 0 comma 1. So actually when you join all the three, you'll get a triangle. Now they are saying Z is a point which is equidistant. So which is a point equidistant from the three vertices? It is obviously the circumcenter. Because circumcenter andre enappa? Circumcenter means you are drawing from this point a circle which touches all the three. Andre, this distance is radius, and this distance is also radius. This is also radius. So this is what is circumcenter. So how many such points you will find for a triangle? How many circumcenters are there? There is only one circumcenter. So therefore, the number of such complex numbers which satisfies this kind of inequality, this kind of equality is only 1. So anytime they say mod of z minus z1 equal to mod of z minus z2 equal to mod of z minus z3, it is nothing but the circumcenter formed by joining z1, z2, z3, whatever triangle you get, uska circumcenter is what they are talking. Okay, so note this down. Let's move to the next question. 85th one. Z is 9 plus p iota. And they're saying imaginary part of z square and z cube are equal. So let's find out what is z square. Z square is nothing but a square plus b square plus 2ab. So idralli imaginary part is only this. So I can say 18b is the imaginary part. Z cube andre a plus b whole cube ಮಾಡಿ. What is a plus b whole cube? A cube plus 3a square into b plus 3a into b square plus b cube. ಇದರಲ್ಲಿ imaginary terms ಅಂದ್ರೆ ಯಾವುದು? Imaginary terms are second and last. So there are two imaginary terms. 81 into 3, that's 243. 243bi, 243b anta baritini because imaginary means except I. So 243b, and here imaginary term is I cube. I cube ಏನಾಗುತ್ತೆ? I cube is minus I. So I'll write like this: minus b cube. 243b minus b cube into I should be equal to 18bi. In the imaginary is this full 18bi, and here you'll get like this. So ಎರಡನ್ನು equate ಮಾಡಿದಾಗ you'll end up getting 18b is equal to 243b minus b cube. So b cancel ಆಗುತ್ತೆ. So then I'll get b square is 243 minus 18, which is 225. So b will be 15, no, 15 square. So b is plus or minus 15, but we can take b as 15 because negative integers they're not told here. So b by 3, 15 by 3 will be how much? 5. Okay. So please note this down. Let's move to 86. 86th, they're saying omega is an imaginary cube root of unit. And they're asking how many pairs of integers a comma b exists such that mod of a omega plus b is 1. So you can write omega if you want. Omega can be written as minus half plus iota root 3 by 2. Now this mod should be 1. So group all the real terms. So you'll have real terms are b and minus a by 2. So this is the real term. Imaginary terms is this, right? So now I can help you do this a little faster. We know that mod, right? Mod will be 1. Whenever we know that sine square theta plus cos square theta should be how much? So here we have root 3 by 2 whole square. How much is that? That is 3 by 4. So that means b minus a by 2 whole square. B minus a by 2 whole square should be 1 by 4. Or b minus a by 2 should be half or minus half. So if b minus a by 2 is half, then b minus a by 2 must be half, and or minus half. So if b minus a by 2 is half, one possibility is you can take b as 1, a as also 1, right? So 1 minus half. Are there any other possibilities for b minus a by 2 to be, oh, I forgot here. There's a a multiplied here also, right? So will be here 3 by 4 a square. So now it's a different thing altogether. So here, this whole modulus, you should equate it to 1. So now when you equate it to 1, let us see what we get. So you will get b square plus, here you will get a square by 4 and here 3a square by 4. So you'll get b square plus a square minus ab. This should be 1. B square plus a square minus ab should be 1. Or if I take everything to this side, let's, am I correct here? B square, yes. This should be 1. So then I can divide throughout or let's write like this 1 plus ab minus b square minus a square equal to 0. So now factorize this. So when you factorize this, you get 1 minus b into 1 minus a. No, don't get this. So now you'll have to see how to factorize this. Probably we can write this. This we can write as a plus b. Let me just tell you how to simplify this further. We will maybe look at next question first. Just remember this equation. We'll come back and see how to solve this. B square plus a square minus ab equals 1. We'll just look at that. So next one is quite easy. Just write z as x plus iota y. Mod z will be root of x square plus y square. You should equate it to 2 plus 8i. Imaginary parts on both sides should be equal. So comparing, I can directly say y is how much? 8. Now, once you know y is 8, the real terms on LHS is x plus root of x square plus y square is 8 square 64. This should be 2. So take this to the other side. Then square on both sides. So x square plus 64 is 2 minus x whole square. Get here x square minus 4x plus 4 square plus 64. So you'll end up getting x as minus 15. X is minus 15 and y is 8. So that means mod z. How much is mod z? Mod z is root of x square plus y square. So this is 17. So 17 is mod z minus 8. So 17 minus 8, answer is 9. So this is a way to solve this question. Now 89th, 90th, let's do them quickly. 89th question. They are saying f of x is an odd function. Odd function means when it should be like some x power odd number. That way. Why? Because odd function means when you put minus x, answer will also be negative. Like if you look at, if I take f of x as x cube, what is f of minus x? It is minus x whole cube. Just simply minus of x cube. So whenever this type comes, it's an odd function. So now this portion is very important. Whenever you see f of x plus 2 is f of x plus f of 2. This indicates that the function f of x must be a linear function like mx. Why f of x has to be mx? Obvious, because what is f of x plus 2? F of x plus 2 is m of x plus 2. Now when you expand, so you get m of x plus 2. Now what is f of x? So isn't m of x plus 2 equal to f of x is nothing but mx. So f of 2 is nothing but m into 2. Now mx plus m into 2, is it not m into x plus 2? So anytime you hear f of x plus alpha equals f of x plus f of alpha, immediately you should write f of x as mx. Okay. So what is the function? F of x is mx. Now f of 1 they have told is 3. So put here f of 1 is equal to m into 1, and f of 1 3 anta hakidare. So instead of f of 1 you put 3. So you'll end up getting m is 3. So once you know m is 3, your actual function is f of x is 3x. So ಈಗ f of 3 ಕೇಳ್ತಾ ಇದ್ದಾರೆ. x ಗೆ 3 ಅಂತ ಹಾಕಿದಾಗ f of 3 you will get as 9. That is the answer. This is a easy question provided you knew that f of x plus alpha should be written, when it's written as f of x plus f of alpha, that means f is a linear function. Okay. Now this question, 3 by 4, 6x plus 10 minus x square. This I can write as 3 by 4 whole cube. Here the trick is, many students think this should be less than 3. But the trick is, whenever you have a number less than 1, inequality will reverse. That means 6x plus 10 minus x square will be greater than 3. And this applies only when the base, right, is less than 1. How to understand this? Very easy. 1 by 2 power 1 and 1 by 2 square. Which is bigger? Obviously 1 by 2 power 1 is bigger. 1 by 2 power 1 is bigger than 1 by 2 square. So although 1 by 2 whole power 1 is bigger than 1 by 2 whole square, 1 is not greater than 2. Rather 1 is lesser than 2. So whenever the base is less than 1, the inequalities of the powers, right, when you're comparing the powers, you should reverse the inequality. That's why we are reversing it. So now transfer everything to the other side. So you'll get 0 is greater than x square minus 6x minus 7, or x square minus 6x minus 7 less than 0. Now when you factorize this, less than 0, right? So now which are the integers that satisfies? Using wavy curve, we can say that between 1 and 7 it will be negative. So in between, which are the integers? 2, 3, 4, 5, 6. So the answer to this is number of integers satisfying this inequality is 5, which is 2, 3, 4, 5, 6. Okay. So now the next question. They're saying A is greater than 2. And they're saying there are 18 integers satisfying this inequality. Andre x minus a x minus 2a x minus a square is less than 0. So whenever they give like this, how do we proceed? We use the number line method. I know a is going to come here. 2a will come here. Now where will a square come? It depends on the value of a square. Now a is greater than 2, they are saying. So put a as 3 or 4. 2a is 6 and 2a here is 8. But a square, how much is a square? A square is 9 and a square here is 16. That means a square is going to be even bigger than 2a. So a square will come here. So now by wavy curve method, here it will be positive, here it will be negative, here it will be positive, and here it will be negative. Right. And they are saying that the number of positive integers is 18. So that means here how many ever integers are there? And here how many ever integers are there? Both of them put together is 18. Now how to find how many integers are there here? How many integers are there between 3 and 5? There's only one integer in between 3 and 5. What is that? 4. But when you subtract 5 and 3, what do you get? You get 2, right? So to find number of integers, what we have to do? You subtract the upper and lower. You'll get 2, but that's not the right answer. You should minus 1. So same way, how many integers are there between a square and 2a? It is a square minus 2a minus 1. Similarly, here, now from a till where will it go? They have told a is greater than 2. Andre minimum ಎಷ್ಟು ಹೋಗಕ್ಕೆ ಸಾಧ್ಯ a should be greater than 2. Between a and 2, how many integers are there? Again, same logic. A minus 2 minus 2. So both of them put together, what they are saying is 18. A square minus, then I simplify minus a plus a will become minus 2a plus a is minus a. And here you'll have minus 4 is right? Minus 4 minus 18 minus 22 is equal to 0. There are just 18 positive integers satisfying this, right? So now how to solve this? Here there's a slight mistake, I think, in the question. They should just say a is simply greater than 0. Or maybe a is simply a natural. Like, so if they say a is natural number, then can even take 1. Okay, now they're saying a is greater than 2. But if a is greater than 2, I don't think we'll get any answer. So if they say a is any natural number, Then between 1 to A, how many possibilities are there? There are A possibilities. So then you may get some answer. But nonetheless, here one thing is sure, A square is equal to 22 plus A. That means A should be at least 5, right? Because A should be 5. You will get exactly 5 if, let's say, this -1 and -1 are removed, right? So, as far as I understand, there's some mistake in this question. Either it should be less than equal to 0. Something like that should be. If it's less than equal to 0, then I don't have to subtract this one. I don't have to subtract this also. So then I'll get A square minus A minus 20. Now you'll get progress. A square minus A minus 20, which is A minus 5 into A plus. So A has to be 5. So that way you can say A is 5. Next question. We had to solve this, right? A omega plus B. Let's do that. So we arrived at this equation, right? A square plus B square minus AB equals 1. So now we'll have to use inspection. If one of them is 1, another is 0, there are 4 combinations, right? 1 comma 0 minus 1 comma 0 comma 1, 0 comma minus. These will satisfy. So the answer to this question is there are 4 pairs. A comma B. So hope this was useful. Thank you, students.